Okay, so because I won't be available after school today, I wanted to upload some problem set questions because I'm sure not everybody can come in early in the mornings, and it's probably not best to come in with questions right before the quiz anyway. So I'm going to do some questions from problem set 2. There are a couple questions in problem set 2 that we've already done in class. Like, for example, we did this question from the AP exam in 2016 on the first day that we were together in class. So try to find that one as a reference. And then this question here was what we did in our notes. And remember, the key to my notes is always going to be posted online, just not the key to my problem sets. But sometimes I'll upload videos like this to help you out. Okay, so this is like a warm-up stoichiometry question. It says methane gas reacts with chlorine gas to form dichloromethane and hydrogen chloride, as represented by the equation above. A 25-gram sample of methane gas is placed in a reaction vessel containing 2.58 moles of chlorine. This is a red flag. Every time you see two amounts of both of your reactants, you should think limiting reactant question. So they're telling you there is a finite amount of each thing here. So automatically, limiting reactant question, something's going to run out. So it says identify limiting reactant when methane and chlorine gas are combined. Justify your answer with a calculation. So I know Mr. Payne solved it a quick and easy way. I'm just going to solve it the long way. That way you can see how it works. So I have a 25-gram sample of methane. Methane is CH4. And then I have a 2.58 mole sample of chlorine gas. 2.58 mole sample of chlorine gas. What I'm going to do is I'm going to set up two stoichiometry problems. For each problem, I'm going to solve how much product I can make. And some of this is, I can choose this product or I can choose this product. It doesn't really matter. I'm probably going to choose this one here. That way, by looking ahead, I already started problem 2. But it doesn't matter which one you choose. So whichever one gives you the least amount of product means it's going to run out. And that's going to be your limiting reactant. So for this one, we're starting with grams. You cannot solve any stoichiometry problem with grams. You've got to get to moles because you balance your chemical reactions by using moles, like drawing those pictures. So for every 1 mole of methane, we need 2 moles of chlorine gas to react to get 1 mole of dichloromethane and 2 moles of hydrochloric acid. Okay, so the molar mass of methane is 16.04. Got that from the periodic table. So now my grams of methane cancel. Now, for every 1 mole of methane, I will produce 1 mole of dichloromethane. That's my molar ratio. Some people call this the mole bridge, others call it the molar ratio. It's the same thing. I'm going to stop here because whichever gives me the least amount of moles will also give me the least amount of mass. So let's see what we get. 25.0 divided by 16.04 is 1.56, okay? Moles of this product, dichloromethane. All right, let's do the other one. So this is already a mole, so I don't have to do an additional step. Because it's balanced by using molar ratios, I only need to use moles when I'm using my chemical reaction. So for every 2 moles of chlorine, I can go ahead and do my mole bridge or my molar ratio. I'll produce 1 mole of dichloromethane. So my moles will cancel. So 2.58 divided by 2 gives me 1.29. So because my chlorine will produce less moles than my methane, this is my limiting reactant. Chlorine is my limiting reactant. Once I have used up all these moles of chlorine, I cannot make any more dichloromethane. So this guy's going to be my excess reactant. So this question says, calculate the total number of moles in the container after the limiting reactant has been totally consumed. That's it. My limiting reactant is chlorine. Once it's done, you can't make anything else. So this is my final answer. So that one was pretty quick and easy. Hopefully it was a good warm-up question for you.